Here comes spring. I am Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, March 23rd. Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype. If you enjoy the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of your screen. If you have a comment or a question, write it up down below. And if you'd like to make a contribution to the cause, you may. Hit the super thanks button down below, the heart with the $sign in it. With that, I'd like to thank the folks that donated last week. Diane's Game, new contributor. Mont the Drifter, Our Predicament, Tim Caston, Evolution Moto, these are all our longtime contributors, always appreciated. California Gold Surf Auction, another new contributor, and Mark Herlock, our big contributor for the week, and I believe Mark has donated a time or two before. So with that, let's get to work. We'll start by taking a look at current conditions across the planet. Starting up in the North Pacific, there's a little gale, remnants of a stronger gale that was over by the dateline with still 20, 21-foot seas, something like that. Swell from that is starting to hit Hawaii and bound for the U.S. West Coast. Down in the southern hemi, we have a strong gale here with 38-foot seas. Mainly going to affect Chile and Peru. It's just blowing up right now. I don't think it's going to have any impact up into North America or Hawaii. But then we also see a series of gales off to the west of that with 22, 23-foot seas and 20-foot seas. So clearly, the southern hemi is coming online, consistent with the title of this video, that spring is here. In the North Atlantic, we see a weaker pattern, again consistent with the northern hemi losing energy. 18, 19-foot seas up here, but fading a little bit at a time. Southern Atlantic, not a whole lot going on at the minute, but I think there is some better opportunity in the future. And then over in the Indian Ocean, a gale with 24, 25-foot seas south of Australia. But before we get into all that, let's go take a look at current conditions. We're going to start off of North Oregon, the Pacific Northwest, the border basically between Oregon and Washington. Grays Harbor buoy, buoy number 036. We're looking at all the energy that's hitting that buoy all the way up from 33.3 second period. Very energetic swell energy, if there were some, but there isn't any. We do see some bumps of energy out here in the 18, 15 second range. And then this chart goes the whole way down to 5 second period swell energy. That'd be basically pure wind chop, not even really rideable, just sort of trash up the surf conditions. We do see a bump here at 8 seconds and then the other bump at 15 seconds. Let's see how well the algorithm does at sorting it out. The largest swell is indicated first as the primary swell, 7.2 feet at 8.6 seconds from 249 degrees, theoretically making surf at about 6 feet. This would be at your generalized nondescript beach break with no swell enhancing bathymetry or anything like that. Secondary swell, 4.3 feet at 13.7 seconds from 280 degrees, theoretically making surf right at about 6 feet. Then we come down to Northern California. We'll use the Point Reyes buoy 029 off of just north of San Francisco. Same sort of a pattern, but more energy in the 15 to 16 second period range, and then some of that wind swell bump in the mix as well. Primary swell 6.8 feet at 15.6 seconds from 301 degrees, theoretically making surf 10.6 feet. That would be at any unshadowed breaks. Secondary swell 7 feet at 12.4 seconds from 303 degrees. And again, another 8.5 feet. You know, the two swells not adding together, but just coexisting at the same time. Then we go down to Southern California, the Point Loma South buoy, number 191. That's effectively off of San Diego. We see a much more muted pattern, of course, all this energy coming from the north, at least for the moment, though southern hemiswell does appear to be in the forecast. That's sort of a teaser there. So the Channel Islands, of course, block a bunch of the swell, but you get the general idea. Primary swell 2.8 feet at 13.4 seconds from 247 degrees. And the secondary, theoretically making surf 3.8 feet. And the secondary swell 3.4 feet at 10 seconds from 278 degrees. Again, surf height in about the 3-foot range. And that's pretty much what it is. And then finally, over to the north shore of Oahu, the Waimea Bay buoy, number 106. Clearly, there is real swell hitting this area in the 18-plus second period range with some lesser wind swell in the mix. Primary swell, 5.4 feet at 18.5 seconds from 309 degrees, theoretically making surf right at about 10 feet, and that's pretty much what it is. With secondary swell 2.8 feet at 15.3 seconds from 312 degrees, adding another 4 feet of surf in the mix there. All right, so what has been going on since our last video a week ago? This is the Hindcast data. We're going to just blast through looking at the whole planet real quick, just so you get sort of a sense of, well, is there a transition from the north moving south? And, just sort of eyeball it. I'm not going to stop and describe each one on this chart. You do see the southern hemi doing better, and the northern hemi, well, there still was a pretty good solid gale up there on Friday in the North Pacific, but it looks like the general trend, now we've wrapped around. The general trend is more towards the southern hemi, less towards the northern hemi. Let's go drill into the details now. Starting in the North Pacific first, we're back to Sunday, March 16th. Little gale here was off of California with 20-foot seas. Another gale over the north or the Dateline region, but not really doing a whole lot. Then on Monday night, a gale pushed off of the South Kuril Islands with 37-foot seas. These are the highest seas over this entire domain, pushing off to the east. This system pushed up to the North Dateline region, faded with 28-foot seas into Wednesday. Swell from that system is currently hitting California. Another gale developed off of Japan on Thursday, the 20th of March, with seas building to 37.7 feet on the dateline, then pushed over the dateline, slowly fading. You see the leading edge of that swell right as we speak are poised for Hawaii, and in fact, it is hitting Hawaii today. We go to the southern hemi, again, looking at what has happened over the past week. Generic gale here, building off of Chile and off of Chile with 32-foot seas. That was on Wednesday. But then another little gale here developed south of New Zealand on Wednesday evening into Thursday, the 20th of March, with 31-foot seas, lifting pretty decently to the northeast. Swell is expected from this system for Hawaii and into the U.S. West Coast. Nothing huge, but a start. Then a stronger gale, actually, not theoretically, but actually developed south of New Zealand with, and this was on Friday, so just a couple days ago, 37.9-foot seas, and there was this southerly fetch component here. Notice how the ice anomaly that we've been watching is finally cleared up, and the ice is well retreated. It's just past the peak, almost 3 months past the peak of summer now in the southern hemi. So, and there we go. Right about there, we got max seas 40 feet, continuing while the system pushed off to the east. Now it looks good on paper, but this system, if you really follow the track, most of the fetch was either pushing to the east or almost the southeast, just this little component pushing north. Don't think there's going to be much swell for Hawaii, but Southern California should get sideband energy from that system. And then another system, as you can see today, is starting to build off to the west of the southern tip of South America. In the North Atlantic over the past week, it's been a series of gales, basically some sort of a trough aligned right here off of Europe, targeting Morocco and Portugal. There was one there on, what was that, Sunday, another weak one on Wednesday, and then another one, here we go, on Friday. Again, all aimed well to the south is Friday the 21st, and then pushing inland on Saturday, that'd be yesterday. The expectation is this pattern will slowly be fading now as things start warming up in the northern hemisphere from a temperature perspective. South Atlantic, we'll just roll through this. This is starting on the 16th of March. Not a whole lot happening. Not abnormal for this time of year, though at some point here, one would expect to see a building pattern in this area. And then finally, in the Indian Ocean, gale south of Australia with 32-foot seas, something like that, enough to produce swell in that area, and then fading. Tropical system falling south, probably turning extra tropical, but didn't do a whole lot. But then we got into Wednesday. A gale developed, I guess you'd call that southeast of South Africa with 37-foot seas to 38 feet. On a pretty much due east heading, so that still some sideband energy from that could likely work its way north up into Bali and Mentawai Islands, and of course into Western Australia. You can see the chart right about there. You see swell starting to push its way up and away from that gale. All right, so let's drill in now. We're going to again look at the Northern Hemisphere and North Pacific. That is our main area, our main focus of our forecast. We're going to start by looking at Jetstream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. We're looking for a trough, a dip in the jet to the south. You see it right about there. That helps support a counterclockwise flow aloft and down at the ocean surface, and that is the hallmark of low pressure. And of course, low pressure, if it's strong enough, generates winds. Those winds get traction on the ocean surface and generate seas. Those seas eventually start radiating away from the fetch area. The lesser period elements decay off, exposing swell, and swell, when it hits your beach, turns into surf. So the jet is somewhat consolidated, pushing off Japan on about the 30th north latitude line to a point north of Hawaii. There is some energy peeling off here. And then that starts falling south, creating the aforementioned trough here. Probably not a whole lot going on there. And then the jet splits just basically north of Hawaii, with the northern branch going into the Pacific Northwest, as it has done all winter. The southern branch over Cabo and southern Baja not doing anything. So that's kind of the pattern. Let's see how this plays out as we get into Monday. Same sort of deal. Things actually getting more muddied over here in the west. Yes, winds to 160 knots in one pocket, but jet almost starts looking like it wants to split there. It's still fully split off the U.S. West Coast. That supports, when you have a split pattern like that, high pressure over the U.S. West Coast. So lack of rainfall and protection, hopefully a light wind regime. Then you notice we get this sort of I'll call localized trough setting up Tuesday night into Wednesday off the U.S. West Coast. That should support gale development. Also notice some energy falling down into it as we get into Thursday. The jet really splitting here in the West Pacific as we get into Friday. Another little trough on like Friday night, Saturday, and then another one starts building as we get into Sunday off the U.S. West Coast with good energy pushing into it. We'll see what this does in terms of support for gale development. But back to the west, look at the jet going way up into the Bering Sea, then falling south, and just a complete mess over here. Not unexpected, one, because the inactive phase of the MJO is in control. We'll talk about that in a little bit, and that tends to steal energy from the jet and makes it split. And two, we're just getting late in the season. So we go down to the surface level pressure, surface level winds as of today. Yes, a weak little gale of some sort here over the North Kuril Islands and Kamchatka, Aleutians there, and some sort of a weak low hanging out in the Gulf of Alaska. There's your high pressure nestled between the split jet stream flow off California, with northwest winds pushing down the coast. So the real interesting part is we're going to be looking to see how much trades, and in California's case, this time of year, northwest winds are trades. For Hawaii, that would be easterly winds. The stronger the trades, that means the stronger the high pressure in this area, and that means the more the upwelling and the colder the water gets in this area. and kind of just makes wind swell, but it also kind of just trashes things up. So we'll kind of be keeping an eye on that. But as we get into Monday, a generalized light pressure pattern, not a whole lot going on. Then we get into Wednesday. The first gale starts winding up here off the Pacific Northwest with 45-knot winds targeting most of California. Another kind of a cutoff low here over the date line, but all the fetches aimed east. Nothing really for the Hawaiian Islands from that. But as we get into Wednesday and Thursday, you see the gale here getting pretty solid indeed, and then lifting north up into British Columbia. I think there's another one that was forecast. Here we go, right here on Saturday, off the, again, off the North California coast with 45-knot winds targeting, again, California, but also lifting fast off to the north. It'd be probably good for raw, kind of local swell. If you got some protected break, that'd probably be the best call. And then we're into 180 hours out. The greater winter storm generation area out here appears to be pretty quiet and not unexpected for the time of year. So what effect will those winds have on the ocean surface? Well, we know there is some sort of a trough and remnant low pressure hanging here in the Gulf of Alaska, 20-foot seas. That from a previous stronger system back over to the dateline. And that just sort of fades out and decays. Then we get our next gale off the Pacific Northwest on Wednesday. And again, that cutoff low with no seas really aimed at the Hawaiian Islands. 29-foot seas about midday Wednesday, continuing in the 28 to 29-foot range. Then 30 feet Wednesday night off of the Oregon-California border and winding up, pushing inland to the Pacific Northwest. And then we know there's another one forecast. Here it goes on Sunday. So this is almost a week out, the 30th of March, with 22-foot seas building to 28-foot. But again, it's sort of very close to the coast. Don't know how, certainly nothing south of Point Conception, but maybe central and northern California with some luck. We'll get some swell out of that. And there we are, 180 hours out. Then we go to the southern hemi. So there have been 2 gales already. Swell from both of them is expected, radiating north. Let's see if we get lucky. And then, of course, there's this gale here off of the south end of Chile with sea heights at 38 feet. Again, that will likely push swell up into Chile and Peru. Not sure about Central America, maybe some small sideband swell, but it's again aligned pretty much west to east. After that, let's see what the pattern gets. We have 26-foot seas. That's probably not enough for any meaningful swell. We'll call it maybe background swell for maybe California, but mainly Central America and down into Peru and Chile again, South America. Behind that, is there anything else? We'll just roll through here and see. We're really looking for, there we go, a little gale with 33-foot seas. I think it really is going to do that same thing where it falls southeast. You really need the gale to push up to the northeast with seas above 30 feet to give you some sort of a 16, 17 second period swell that will survive the journey and make it up across the equator and into the northern hemi. And there we are, 180 hours out. And no real obvious swell-producing gales are depicted. To the North Atlantic, we know there's been that sort of downward falling trough thing going on in that area. Just keep rolling this out, don't see any more of that. In fact, we're already out to Thursday, the 27th of March. There we go, some sort of a 18, 20-foot seas impacting Ireland, but none of these monster storms or monster swells look apparent or obvious anytime soon. Little gale there off of Newfoundland, but sort of looks like winter is winding down. For the South Atlantic, we'll put this into motion. That gale that transited the far southeast Pacific fades out and doesn't make it into the South Atlantic. But another gale forms right behind with 36-foot seas. Now, this is a good long ways away from South Africa and lifting a bit to the northeast, maybe some swell from this, and it holds together even with 20, 22, 24, maybe 25-foot seas. So, yes, and you can see a swell front right here pushing into South Africa. That'd be Southwest Africa. So swell from that for sure. And then that was it. So one system for the next week. We'll go back to the last frame there for potentially for Africa. And then the Indian Ocean. We'll put this into motion. If anything, we would expect that things would be starting to wake up in this area. But as of right, there's tropical system as on Friday, but things looking reasonably quiet. One small gale. We're out to Saturday, the 29th of March with 38-foot seas. Again, taking that west to almost southeast kind of heading. So that's not necessarily good news. Tropical activity in the mid-Indian Ocean. And there we are 180 hours out. So then we start looking for, again, the trade wind indicator or winds for California. There's California there. There's Hawaii. We're looking hopefully not for some like big high pressure setting up, creating nuking northwest winds down the California coast and blasting easterly trades into the Hawaiian Islands. But it would not be surprising if we were to see that. The more of that you see, then that suggests the stronger the effects of La Nina on the oceans. But if high pressure more or less holds itself at bay, then that suggests that the current Modoki La Nina state that we're in doesn't have a particularly strong footprint. So Monday, I was looking just no real winds, light trades for the Hawaiian Islands. Tuesday, light wind regime for California, light trades for the Hawaiian Islands. Wednesday, here comes the low pressure, so you're not going to get a whole lot of high pressure around that, and it's a light wind regime for California and trades southeast at 10 knots for the Hawaiian Islands. Thursday, now you see high pressure trying to nose in here behind this low, but at least on Thursday, reasonably light winds. There's south winds up in Cape Mendocino. Trades light for the Hawaiian Islands. Friday, same sort of deal, but you can just see high pressure wants to set up. Will the atmosphere support it? Don't know. Right now, winds not too bad on Friday. Same light winds for the Hawaiian Islands. There's proper, and then here comes the next low, so you're guaranteed to still get a lighter wind regime. High pressure cannot get a footprint off of California. Trades light for the Hawaiian Islands. We're into Sunday. Same deal. Actually, a cold front pushing down to maybe near Santa Cruz. South winds. We'll believe this when it actually happens. Let's see. And yeah, the front pretty much fades out right about there. And high pressure trying to get a nose in the door, but not doing it. And winds a little bit south for the Hawaiian Islands, but probably not too bad. Precipitation forecast for California. Just any shade of blue anywhere in California would be a welcome thing, but especially south of San Francisco. First front comes in, you see rain. San Francisco, where is it? Right there. You see actually rain in the Sierra, snow on some of the higher peaks, Mount Whitney's down there. And then that continues like Wednesday into Thursday. Nothing makes it south of San Francisco yet. Nope. And even the end of the front of this, and you see not even any snow really in the Sierra. A warm system is what it's looking like. Next system sets up off the coast on Saturday. Will we get a little bit better? There we go. Actually, looks like real rain on Sunday down to Monterey Bay, maybe even Big Sur, but not much further south than that. I'm looking at the Sierra here. Snow in the Sierra on Sunday. I'm going backwards, just sort of, yeah, but probably, and then rain. So it's a higher elevation thing. I mean, clearly this just reeks of a springtime pattern where it's not cold enough to really get any good snow going. You see it even the whole way up here into the Cascades, and we're 180 hours out. So liquid precip, for the most part, seems to be the theme. The snow forecast dashboard for Palisades, Tahoe, formerly Squaw Valley, about 6 inches, something like that, all sort of scattered along as those fronts try to come in, but really focused between about the 29th, the 30th into the 31st of March. Looking down at Kirkwood, well, they just have higher elevation, so you can wring more snow out of it because it's probably colder, and you theoretically 14, 15 inches, all on the same period as before. And Mammoth Mountain, though much higher with the base elevation somewhere around 8,500 to 9,000 feet, depending on which base area you're at, and the summit up at 11,000 feet. But because it's further south down the Sierra, less precip is pushing down that way, so 5, 6 inches, something like that. Then we go look at freeze levels for Palisades, Tahoe, good representation of the Sierra. This is the base of Palisades, Tahoe, that at about 6,200 feet. The summit up at the top of Granite Chief and the Palisades themselves, right at about, it's 8,900 feet or 9,000 feet here. Red is liquid precip, gray would be sleet, somewhere between 35 to 32 degrees. The border between the gray and the white, that's the 32-degree freeze line, and blue is 28 degrees. That's really the start for good snow production and good snowpack on the roads, that sort of thing. You see the freeze level the whole way up at 12,000 feet and holding into the 25th of March, so that's like on Tuesday. Then it starts falling and actually gets down. The freeze level goes below the base down to 5,500 feet on the 27th. Tries to poke up a little bit, but still basically holds the whole way into the night of the 28th of March. After that, freeze level up to 8,500 feet again on the 29th through the 30th. Trying to come down, but only making it to about 7,000 feet on the 31st, and then heading back up from there. All this, especially this, huge sign of some sort of spring pattern setting up. All right, so what's the surf forecast? We'll start again up at off of Oregon, the Oregon-Washington border, Columbia River. Surf heights dropping here as we get into, well, Sunday into Monday in the 6-foot range, 7 feet on Tuesday, 8 feet on Wednesday, and then with the first gale off the coast, they jump back up into the 20-foot range. You can also see winds out of the south at 35 knots, something like that, so pretty windy, and then things start dropping off only to start rebounding to the 18-foot range as we get into Sunday a week from now with the next low off the coast there. Swell heights, so 6 feet, 5 feet at 11 seconds, then actually some real swell shows up 4.5 feet at 16 seconds, working its way onshore, then building up to 14 feet at 13 to 14 seconds. This would be on Thursday, the 27th of March, and then fading from there, only rebounding to 14 feet at 13 seconds as we get into Sunday next week. Going south to the San Francisco Bay Area, Ocean Beach, California, surf heights in the 6-foot range on Monday, Tuesday, maybe 8 feet on Wednesday, up to 18 feet theoretically on Thursday as that big swell hits, and then dropping from there. Winds during the peak, supposedly not too bad, onshore at like 9 knots sort of thing, so right on the cusp of being kind of junky, but not unreasonable. Not like out here where you have south winds at 30 knots. This would be a week from now, so something to consider. Let's go look at swell heights. 4 feet at 14 seconds on Monday and fading the 13 to 12 to 11 second range on Tuesday. Sort of pulsing again as we get into Wednesday. The next swell from over the dateline hits 4.5 feet kind of thing at 14 to 15 seconds. Then things get big, 12 feet at 14 to 15 seconds on late Thursday into Friday, and then fading down from there. San Diego surf heights, pretty small on Monday, but coming up a little bit, 2 feet, fading down to about 1.5 to 2 feet sort of thing into Wednesday. Trying to come up a little bit as we get into Friday, maybe 4-foot surf. At least the wind pattern looks quite nice. Swell heights. All right, so here's the interesting thing. We have, 2 feet fading to 2 feet at 7 seconds, just local wind swell. Little southern hemi swell starts creeping in here. 1.2 feet at 13 to 14 seconds. Another 1 foot at 17 seconds sort of thing to 1.5 feet at 16 seconds. This would be on Wednesday. So a hint of, or a taste of summer, if you will. And then we get back into more of a winter regime. You see the arrows here, west swell, and really be northwest, probably like 295, maybe even more up in Southern California. 5 feet at 7 to 8 seconds, and you get the drill. The North Shore of Oahu, here we go. So as we're into Sunday night, early Monday, 12-foot surf. So the swell continues up overnight, then starts fading in Monday with surf heights 10 feet and fading from there, slowly dribbling down to almost nothing. And after that, what do we get? A little push of some 4-foot surf on Friday. But you saw the pattern in the generalized North Pacific not doing a whole lot in the long term. Winds generally light. What do we get? One little gust here from the northeast at 17 on Friday, and sort of standard trades, 15 knots on Saturday. Oh, and swell heights. Let's take a look at that. 8 feet at 15 seconds on Monday morning, slowly dribbling down to 2.8 at 11 seconds as we get into Wednesday. And after that, I'm just looking at the periods here, all 10-second or less, so it's just pure wind swell after that. And a quick look over in the Indian Ocean, Bali, that area. Surfs as we get into Monday, 5 feet up to 6 feet on Tuesday, kind of hanging in that range. Maybe a little spike up here in the 8-foot range on Thursday. That would be from that swell coming in from the, I guess that'd be the southwest, and then slowly fading from there. Winds out of the west, pretty strong here on Monday and Tuesday, but then fading, sort of collapsing, and then picking back up westerly winds, 20 knots as we get into next weekend. Swell heights, 4 feet at 15 seconds sort of thing. Another little pulse here, 4.5 to 5 feet at 15 to 16 seconds, and then slowly fading out into the 2 to 3 foot range at 11 seconds. So already, and you see the swell angles here, all out of the southwest. So a building summer-like, I guess actually in the southern hemisphere, it'd be winter-like swell pattern trying to get a toe in the door. Right, let's go take a look long-term. The two major weather oscillations that affect surf and swell production, both in the northern hemi and the southern hemi, the MJO, the Madden-Julian Oscillation, of course, ENSO, the El Nino Southern Oscillation. We'll start first with the MJO, the Madden-Julian Oscillation. It's a periodic weather oscillation that has two phases, the active phase and the inactive phase. The two phases actually rotate around the planet on the equator, moving from west to east. The active phase on one side of the planet, inactive phase, there we go in the camera, on the other, rotating around from west to east. The active phase is our friend. It is like a low pressure system. It takes warm, moist air that's down at the ocean's surface, lifts it aloft up into the upper atmosphere. That energy gets caught by the jet stream, feeding the jet stream, helps consolidate the jet stream and create troughs and, of course, surf. The inactive phase does the exact opposite. It's like a high pressure system. It creates downward falling air. That air basically steals energy from the jet stream. The jet stream gets weak and splits and does all sorts of funky stuff like what we just saw in the North Pacific forecast for the next week or two. That is likely being driven by the inactive phase of the MJO. The inactive phase of the MJO, because it's a high pressure system, feeds the development of trade winds. Okay, you get stronger trades, and then of course, well, that'll make an easterly wind swell in the Pacific, but it will also create upwelling and make water cold. In the active phase of the MJO, because it's a low pressure system, it basically breaks up high pressure, and high pressure is what makes trade winds. So trades get weaker than normal. That actually helps support warm water development. I'm talking specifically on the equator. So we'll get into that in a minute. All right, but let's go see if we can tease out exactly what's going on with the MJO by looking at data from the TAA buoy array, series of buoys strung across the equator used for monitoring El Nino. The active and inactive phase of the MJO really operate in the area just 5 degrees north and south of the equator, maybe 10 degrees, but 5 degrees, that's north, and 5 degrees south. That's like a 600-mile range on the equator around the planet, but we're going to focus really on the Pacific because that's where this buoy array is. There are wind sensors on the buoys. The arrows indicate what the actual 5-day average wind speeds are in that area. So you see trades out of the east here. Oh, this is the equator here. Sorry, that's the West Pacific. This is the East Pacific. That is New Guinea right there. So trades out of the east, not blowing particularly strong over the East Pacific or over the Central Pacific, but once you get to about Hawaii is at 158, something like that. From about Hawaii on west, you see the arrows getting longer. Trades building strongly. That suggests maybe the inactive phase over here. It is, but it's not the actual wind speeds that matter. It is the anomalies, the difference from normal for this time of year. You see those light winds there? Well, the arrows here are actually coming out of the west, suggesting, well, maybe the active phase of the MJO is here, dampening trade winds. But then you get over in the West Pacific and you see trades, well, they're stronger than normal out of the east. So the inactive phase over here, something like that, we'll have to dig deeper to find out. Here's the wind anomaly pattern for the past couple of days. South America, Central America, New Guinea's right there. There's Australia. 0 is the equator, date line right there. So in the West Pacific, you see this sort of a westerly, the oranges and yellow westerly anomalies. So maybe the active phase somewhere around here. Strong easterly anomalies here. So that would probably be the inactive phase. And you just go the 17th, the 18th, 19th, 20th, 21st of March. Actually, the easterly anomalies fading a little bit in the East Pacific. Westerly anomalies, probably the active phase somewhere over in this area. Inactive phase somewhere in this area. So we can see actuals here for a longer period of time, or this is actually modeled. It's 850 millibars zonal wind anomalies. That's up at about 4,700 feet. Now, this is the whole planet here. Here's 180. That's the date line. So the far West Pacific starts at about 125 east, so there. And then the important area for the active phase to be over in the Pacific is right in the West Pacific to a point just about east of the date line. I call it the Kelvin wave generation area. And that's the area when the active phase is over here. And if it's strong during El Nino years, it can create Kelvin waves that then take that a Kelvin wave is actually a push of warm water moving from the West Pacific to the East Pacific, and the MJO is the active component that enables the movement of that warm water that helps usher in El Nino. But we don't have any of that going on right now. In fact, you can see plain as day, the purples here, these are easterly anomalies, stronger than normal trades over the date line, and you see, well, these are the westerly anomalies, and where is that located? 120 west, south of California. Now, this was back in February, and here we are today. Same sort of a pattern. Easterly anomalies over the date line, westerly anomalies trying to get a foothold in the maritime continent, and then fading over here. So active phase probably wrapping around the planet some, trying to build here. We go for the next 2 weeks. These are 5-day increments. They're not actually weekly increments, but you get this sense that inactive phase of the MJO or La Nina, because all the La Nina is basically a preponderance of more inactive phase than active phases. East anomalies continuing till about April 5th, and then they start fading, and then westerly anomalies over the maritime continent, but the entrance is at 125 east to the West Pacific, almost making some headway into the West Pacific. Now, this model updates every 6 hours. I think this is the GFS model. So I've been keeping my eye on this over here, and it kind of gets stronger, gets weaker, goes back and forth. But it sort of smells that something is going on over in this region. As we get deeper in this presentation, you'll see what I mean. All right, so let's go take a look at another component of the MJO, which is cloud cover. If you have the active phase, it takes warm, moist air, it lifts it aloft, it hits the upper atmosphere, condenses, creates more clouds than normal. Inactive phase, because it's like high pressure, does the exact opposite. You get clear skies. So what this is in a model of how much moisture there is in the upper atmosphere. Blues mean more moisture. It's called outgoing long wave radiation. Where is it? Right there. Which is just fancy words for cloud cover. If you have these negative blue anomalies, that means if sunlight beams down through the atmosphere and tries to reflect off the ocean surface, it can't get away from the planet because there's clouds there. So this would be the active phase of the MJO. Inactive phase over here in the Indian Ocean somewhere. All right, so this is a statistical model. This actually shows the active phase building today in the West Pacific, continuing for the next 5, 10, 15 days over the West Pacific. So the active phase getting ready to develop with the inactive phase building strong in the Indian Ocean, and then 2 weeks from now poised to enter the West Pacific. The dynamic model, the GEFS model, suggests active phase just pretty much sitting stationary. Notice the inactive phase not building nearly as strong. Let's see if we can frame up the two. There's the statistic model, the final frame. There's the dynamic model. Clearly, the dynamic model is the one we want to see. The longer the active phase sits in the West Pacific, the better for pumping energy into the jet stream. And that affects not only just the northern hemisphere, but also the southern hemi. So active phase, the correlation isn't quite as good with the southern hemi, where it's almost like a 1-to-1 correlation in the northern hemisphere in the winter up there, but in the Pacific. But in the summer, you can have an active phase here. It feeds the jet stream down in the South Pacific, but it's not as closely tied as it is like in the north. Right, phase diagrams for the same two models, statistic model here, dynamic model here. What is this? What are we looking at? Well, the MJO moves from west to east, from the Indian Ocean over the maritime continent to the West Pacific to the East Pacific, under the United States. Remember, this is on the equator, across the Atlantic, over Africa, that'd be like North Africa, then back to the Indian Ocean. Round and round it goes. The heavy dot is where the active phase is right now. So in the maritime continent, getting ready to work its way into the West Pacific. There's 1, 2, 3 forecast members here. Each of these dots is a day, goes out 2 weeks. This shows the active phase somewhere in the West Pacific to maybe East Pacific. This one member says the whole way to Africa in 2 weeks. That's probably a little bit aggressive. But, and the further the dot is away from this circle, the stronger it is. So you really want to see the active phase like up in here. That's where you're getting a barn buster active phase, and you're going to get a lot of energy pumped into the jet. This looks like a weaker active phase. The dynamic model, the GEFS model, pretty much on track with the same thing. It just shows the active phase kind of meandering around here weekly in the far West Pacific for the next 2 weeks. So we go out a little bit further. This is the 40-day upper level model. The greens area is favorable for precipitation. This is just modeled, and this is a statistic model. So water in the upper atmosphere or cloud cover. Oranges and reds, dry air, inactive phase. There's South America, Central America, New Guinea. 0 is the equator. Dateline runs right down the middle of it. So inactive phase over the Atlantic and the East Pacific, active phase building over the maritime continent. But this is in the upper atmosphere, so this runs about a week ahead of what's really going on at the surface. So really, the active phase would be somewhere over here, and the inactive phase is somewhere in about, maybe in the dateline region. Anyway, each panel, there's 8 panels. Each panel goes out 5 days. So you see the active phase making its transit across the Pacific through about the 12th of April, but add another week on that. So you're into the 20th of April sort of thing. Then here comes the inactive phase setting up for the latter half of April into early May. Next up, the CFS model. It's a dynamic model. And again, it's upper level winds, 850 millibar, but we have the benefit of the MJO actually overlaid over this chart. The black contour is active phase, the dotted contour inactive phase. And let's get ourselves oriented. 180 runs right up the middle of the chart, so that's the date line. Far West Pacific starts about 125 east, so somewhere over in this region. So these are past active, inactive, active, inactive. You see today inactive phase and its associated easterly anomalies over the date line, forecast going till about, April 7th or something like that. Now, what is interesting, you notice there has been almost nonstop easterly anomalies. I mean, it's been going on for months now. That is classic kind of La Nina setup. You notice those easterly anomalies all but dissipate starting about April 7th or 8th. So we're talking 2 weeks out, basically. And notice the active phase building here, working its way into the Pacific, dragging westerly anomalies with it to almost filling half the Kelvin wave generation area. If this were in fact to happen, especially this no trades anymore, or normal trades, I guess you should say, and westerly anomalies building in the West Pacific, that would be a clear sign of some sort of demise of La Nina. In fact, let's go look at one more model. Now, this is the CFS model. It goes out 3 months. Past performance is down here. It's flipped, and the forecast is on the top. You can see this steady out, and the date line runs right up the middle again. You see the blues are easterly anomalies, inactive phase. You see almost continuous, except for like right there and right there. The thinnest of little active phase energy in the past, this would have been in like January, and this was in early February. And then this another big batch of blues, inactive phase of the MJO, easterly anomalies. And then you see, here is today's date, the 23rd. See easterly anomalies starting to retreat about a week and a half from now. Now, I know you're going to say, and you can call me on it in the comments, this model said that really, when I was first watching it, like by March 24th, these easterly anomalies would die. And now it's sort of, well, it's every day it sort of pushes it out a little bit, but it's only saying basically a week and a half from now, easterly anomalies completely die and westerly anomalies take over, not just the Kelvin wave generation area, but a good portion of the entire Pacific Ocean, and they don't stop over the critical Kelvin wave generation area here in the West Pacific. Westerly anomalies supposedly to hold the whole way at least into June. This would clearly be the demise of La Nina if it were to happen. In fact, let's overlay the MJO here, right? So here's our current inactive phase. You see the contours already pushing out of the West Pacific, and active phase contours pushing into the West Pacific. 125 east, there's the magic line right there. So the active phase is already trying to set up. And as we get into, again, that like April 8th date, contours completely filling the Kelvin wave generation area, westerly anomalies taking over. Look at this, actually building kind of moderate in strength as we get into late April, May. Now, does that mean there's going to be some giant push of surf in maybe the North Pacific? Probably not, but you never know. Maybe we'll get lucky. At least I think it would help add momentum to the southern hemi. Then we have another inactive phase, but notice, this would be in like June, late May kind of thing. But notice, westerly anomalies, forecast to continue even during the inactive phase. Even if it just went neutral, I think that'd be fine. Then we have another active phase after that, so you're into like the whole month of June. Let's overlay the low pass filter, and then this will help kick us off into the La Nina, El Nino discussion here. Dotted contours, high pressure bias, the classic La Nina sort of setup, right over the date line with 1, 2, 3 contours. Here's today's date. The third contour to fade, April 16th. The second contour fading about May 1st. And then notice the high pressure bias entirely out of the Kelvin wave generation area as we get into mid-May. The low pressure bias, which is the El Nino indicator, which this winter has been over the maritime continent, is to start actually, you see it starts pushing here in like April 20th, and then actually gets a good toe in the door in the West Pacific by the beginning of May. And by the end of the model run, filling the dateline region with a second contour building. Now, does that mean El Nino is going to set up? I don't think so. But, and I think it's a bit of hype by the model, but it clearly suggests that the model thinks, and it has not changed. I mean, this model has been rock solid, give or take a couple of weeks of waiver here and there, but we're going out 3 months, so what can you expect? It's done a pretty good job of suggesting that that La Nina is to fade, and a we'll call it at least a neutral pattern is to set up over the Pacific. That would be really good news long term as we get into next fall and winter. Right. So what's going on in the ocean? There is a atmospheric component to all this with the MJO, but that atmospheric component affects the ocean. The ocean then changes its warm cold water pattern, which then in turn reinforces an atmospheric pattern above it by shifting where the evaporation happens. Warmer water creates more evaporation, rising air creates lower pressure, and that does things to ocean currents that help set up for either La Nina or El Nino. All right, looking today, this is data from the TAO buoy array again. This is the West Pacific here. This is the East Pacific. The X is right here. These are the anchor lines on those buoys. The X's are individual sensors going down there, so you can see the profile of warm and cold water down in the ocean. And as is normal during La Nina, because trades blowing from east, here's east to the west, tend to take warm water, push it all into the West Pacific. So here is the 28-degree isotherm. It was at, I think, 170 last week. It maybe kind of made a little bit of a return to 171 or 172 east, but it had been as far as 178. So what I think has happened is the inactive phase of the MJO boosted up trades, took the warm water pool, sort of slammed it up against the far West Pacific. And now as the inactive phase is fading in the west, the warm water can sort of breathe a little bit more. 24-degree isotherm, pretty much as it's been, pushing the whole way across the Pacific, though getting a little bit of increase in density in warm water here in the far East Pacific. It is not the actual water temperatures that matter as much as the anomalies, the difference from normal. Warm water here, you can see it 1-2 degrees above normal in the west. Also a pocket of it here in the east. And pretty much, if anything, building. Here is our last of La Nina cool pool with 2 degrees below normal anomalies down about 125 meters at, that's about 160, south of Hawaii, let's say, over, but not getting the whole way into Ecuador or anything. Now, normally I'd be showing you this other, the GOTUS high res, but it is down. The satellite data is down. Not sure what's going on there, but NOAA will, I think actually the satellite and all that's working just fine. They have a data issue of some kind. It's been this way since about the 7th, I believe it was. So it's been almost 2 weeks now, but they're working on it, I'm sure. Upper ocean heat anomalies. All right, so this really paints the picture here. East Pacific here, West Pacific here. The blues, cold waters. The oranges, yellows, reds, warmer than normal waters. This goes back a year. So you see these are cold water pulses feeding La Nina's development off of Ecuador and in the East Pacific. You see most of this is south of Hawaii, and it's not like slammed up against the coast here. Hence the Modoki status. That is La Nina sort of, but not really. And also notice that water temperatures getting warmer. Notice the warm pool building here in the west. We actually have a little pocket of warm water here at 115 west. Now, also notice there is a little white bar here at the bottom. That's a data gap. Normally the whole space is filled. So that's part of that same problem we were talking about earlier. But my suspicion is as the inactive phase moves over the East Pacific, that bit of warm water will get wiped out, but then it'll probably come back after that. Let's dig a little deeper. So that was subsurface temperature data. Now we're going to look at sea surface temperature data. Of course, you see everything. The yellows and oranges warmer than normal. No big surprise. There is South America, Central America, Hawaii, New Guinea there. The equator right there. The date line right there. Here is our Modoki cool pool, which is not really that cool. Bits of bubbles, and it's just 5 degrees north and south of the equator. So if you want to draw a box in your mind's eye, it'd be somewhere like right around in there for official El Nino monitoring. The cool pool there, you also see cool water off of California, in Pacific Northwest. The reality is you have high pressure sitting right here, rotating like that. It's probably, in generalized speaking, stronger than normal, creating this upwelling here. And then this cool pool follows the stronger than normal trades that are around the springtime building high pressure system and then feeding into the Modoki cool pool right there. Also notice a lot of warm water off of Ecuador and the Galapagos Islands here. You would not be wrong if you just looked at this, go, gosh, it looks like El Nino's forming, but it's not. This is, I think, a temporary situation. In fact, let's go look at one alternate chart here. So because the planet's got so much water and, NOAA's coming up with all these schemes to try to figure out, well, how strong is our El Ninos and La Ninas in a warming planet scenario? Another way to look at this is just you take the global mean sea surface temperature average right today and then compare all the measurements against that. You still see that same cool pattern here, but you don't see as much warming up in the polar regions and everywhere else as there is in the previous chart. So a lot of people think that maybe this is a better way to view what's going on. Sure, it's warm here, but you're right under the center of sort of a La Nina-induced high-pressure system. In the center of high pressures, there's not a whole lot of wind, so the sun can bake the ocean surface, make temperatures warmer, sort of things. Just consider that. And there's a high there. There's a high rotating the other way down here. Same thing up here, same thing here. That's what drives the Gulf Stream, you see there. Colder than normal temperatures, though. Look at that. It looks like a colder than normal flow rather than a warmer than normal flow. Anyway, just wanted to show you that. And the sea surface temperature trend for the past 7 days, South America, Central America, the equator right there. You see temperatures, the blues, temperatures cooling. This is where that warm spike was. The inactive phase of the MJO moving over this area. Active phase somewhere over here. So it's no surprise that temperatures are cooling because the trades are probably blowing harder than normal, creating upwelling. I suspect this is going to be a very short-lived thing. Like in 2 weeks, all this will be gone. We'll be back to either neutral or warming temperatures there. Out here in the middle of the cool pool, temperatures are actually rising already, and the active phase of the MJO is still just hanging somewhere over in here. So much more potential for warming over the coming weeks. The CDAS Nino 1.2 index is just sort of a view of the trend. It's not, I wouldn't consider these absolute, they're not adjusted values, but they give you kind of an idea what's going on. This is for the area right there by Ecuador and the Galapagos Islands. Temperatures were cooler, and they have been since in December, like just a half a degree below normal. Then started really warming in February. We were up to 1.5 degrees above normal, but then we've taken a hit today. We're down at positive 385 thousandths of a degree, so a third of a degree above normal. Anything above normal from a surf perspective, not from a atmospheric perspective, is probably a good thing. But the official El Nino monitoring region is called the Nino 3.4 region. It's the area on the equator, 5 degrees north and south of the equator, from a point from 120 west, so basically due south of California, out to almost the date line. Temperatures steadily rising from La Nina territory, so plus half a degree to minus half a degree in water temperatures in this area. That's considered neutral. Half degree to 1 degree below is weak La Nina. 1 degree to 1.5 degrees is moderate La Nina. But you see, even in January, we were already starting to move out of the moderate territory into the weak territory. And then as of the beginning of March, we were basically in neutral territory, and that's where we are as of right now. So neither El Nino nor La Nina, even Modoki-wise, at least per this index, for the time being, nor have we been there since the end of February. The adjusted sea surface temperature anomaly data right here, this is the Nino 3.4 region. This is the Nino 1.2 region. Look at temperatures, 1.5 degrees, 1.3 degrees above normal. This is once a week for March 5th, March 12th. But out here in the official region, well, we were negative. You can see we got down to 1.1 degree, but for the most part, we were just in weak La Nina territory. Then turning neutral the week of March 5th, and now slightly positive is 0.3. Now we know with the inactive phase moving over this area, this is going to get knocked down a little bit, but I think it's going to continue on that rising trend in the future. All right, so what does the atmosphere think is going on? We see what's going on in the ocean, but the air sits on top of the ocean and it responds to warming and cooling patterns in the Pacific on the equator. We happen to have data from Tahiti and Darwin. So in the Pacific Ocean, close to the equator, 20 south, and Darwin over in roughly the Indian Ocean. If you take these two numbers and integrate them, you get a daily value. When the value is positive, that suggests higher than normal pressure over Tahiti in the Pacific. And when the index is negative, suggests lower than normal pressure. Today's value, plus 5.26, which really isn't a whole lot. And just looking back the past month, well, it's been hanging, I'd say, pretty much around neutral, biased slightly in the higher pressure areas, suggesting weak La Nina. 30-day average. Now remember, the MJO is pushing over the Pacific like 4 weeks, 5 weeks on, 4 or 5 weeks off. 30-day average, you can actually see that. Today's value, 6.47. Where were we a month ago? 9.5. So this would be inactive phase, going weekly active somewhere here, maybe in early March, turning inactive as we speak, but that'll be coming around. And then the 90-day average is your El Nino, La Nina indicator, plus 5.09. Where were we a month ago? 7. So in general, La Nina, very weakly present, but fading. So the normal graph we show you of the 30-day SOI, something's wrong with it. It's just not working. I'm not going to show you bad data but this is the same thing produced from the same site. You see the 30-day average value falling. There is 0 right down there. So we were almost at 0 in mid-March. Now we're creeping up slightly, but I expect this will only go up a little bit more, maybe for another week, and then start trending downward. All right, what is the forecast from the CFS model for temperatures in the official El Nino monitoring region, the Nino 3.4 region? All right, so the solid contour is actual numbers. This actually, it was up higher the other day, and these are actuals, but it dropped down now. This is for January, February, middle of March, 1/10 of a degree, maybe 1/2 of a 1/10 of a degree, 0.05 a degree. We'll just call it neutral. By April, the model shows temperatures falling back down to 4/10 of a degree, probably driven by the inactive phase of the MJO. And then after that, now look at this, temperatures neutral by July and up to 4/10 of a degree as we get into December sort of time frame. Now this is the raw data. The PDF corrected shows, okay, a 1/4 of a degree above normal. So basically ENSO neutral. And then we have a consensus model of virtually every other dynamic model here and statistic model here. And just for laughs, there is the CFS model right there. I don't know if you can, boom, right there. You can't really see it, but all these models, when you sum it all together, I'm going to see if I can pull out, there's the statistic average showing temperatures. Well, we'll go look at it in a minute, but basically neutral. The dark red there, that's the dynamic average. Basically neutral as we get into November, December, January. So the December time frame, the end of this year. Let's go look at the actual data values here. So is March, April, May, June, July, and 3 months. There's 3-month bunches, if you will. Here's the data values for all the models, but the average of the dynamic models, 1/10 of a degree, basically neutral, down to 3/10 of a degree below normal in September, October, and then hanging about 1/4 degree below that. These statistic models, what are they doing? They're actually a little about the same thing. 2.91 here, 2.88 minus 3.2 minus 2. So dynamic models, statistic models all seem to be in pretty close agreement. Here's the average of all models. You put it all together, 1/4 of a degree, not even 1/3 of a degree below normal as we get later into next fall. That certainly says to me, ENSO neutral. So for right now, it looks like we have swell hitting Hawaii pretty good. That's eventually going to be working its way towards California. A little bit of longer period energy, probably the last dateline storm of the season. I say that it's mid-March, late March. Yeah, maybe we'll get something in April. I mean, I'm not going to write it all off, but I'd say things are definitely starting to calm down. 2 local gales off of California in the Pacific Northwest probably make for bigger but jumbled kind of surf. Pick your protected break if you want to get some of that. Looking beyond that, rainfall, a little bit of rain here the next week, about a week out for California, mainly we'll say from Monterey Bay northward. Not any significant snow for this year, and my guess is it's going to be a very wet, slushy kind of a mix, even if you do happen to get some snow up high. Looking longer term, Southern Hemi, though, looks to be coming online. 2 small Southern Hemi swells pushing up towards Southern California as we speak. Hawaii might get a little piece of that action as well. We definitely need to see more of that, but again, it's very earlier in the year. I'd say more like April is when I normally even start paying attention, but since there was some activity and there is going to be swell, thought I'd mention it in this presentation. Looking out beyond that, looks like ENSO neutral is coming. We are literally, I was hoping we'd be here by now, but we're literally, let's say, 10 to 12 days away from perhaps atmospherically being able to say that La Nina is all its fundamentals, its underpinnings are going to be ripped out from under it and it's going to collapse. So fingers crossed on that. I look at the model every day and hope that we can at least get back to neutral. I'm so over La Nina. Let me know what you think, though. Most of you, I think, have already written and said, yeah, you're tired of La Nina, too. I mean, it's been years and years of it. We need the PDO to go warm. We'll not get into that right now, but that is the hope that maybe we're going to start nudging our way towards that. I think statistically that's probably not going to really happen, but I'm hoping for it. All right, so that's our forecast for this week. If you enjoyed it, give us a thumbs up. There you go. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of your screen. If you have comments or questions, love to hear from you. Write them up down below. I'll reply for sure. I'm sure some of the other folks will too. And if you'd like to make a contribution to help support the cause, you may. Hit the super thanks button down below. The heart with the $sign in it. With that, we are done for this week. We'll do it again next week. Same time, same channel. Thanks so much for watching.